Now let us see some applications of logarithms. The first application in log is measuring the intensity of earthquake on a Richter scale. As we know that Richter scale measures, the scale of Richter scale is between 0 to 10, right? And you might have noticed a vast difference between the level of destruction that a Richter scale of 6 caused than the level of destruction that is caused by by Richter scale 7. Okay, so you can see that there is just a small difference between the scale from 6 to 7, but the level of destruction is huge. So how this level of destruction, which is, or this difference of destruction, great difference of destruction between 6 and 7 is reduced to just a number 6 and 7. Reduced to just a single digit number, that 6 has been increased to just 7. Okay, it looks like that there is not much difference between intensity 6 and 7, but on the field, practically the difference is huge, right? So in order to reduce the scale, reduce these greater intensity to much smaller scale, logarithm is used. For example, that we know that 2 raised to the power 10 is 1024. Okay, this is a 4-digit number greater than 1000, a big number. But when I reduce this to log, means if I take the log of this LHS, so it is just 10 log 2. Okay, so 10 log 2 means log 2 is just a point number which is less than 1. So this will be around, let us say, 0.177, I think, and this will be, I think, 1.77. I'm not sure, but it is definitely a single digit decimal number. Okay, so this 1024 big number has been reduced to 1.777. So scale is drastically reduced the moment we take log of the variables. So a Richter scale is basically a logarithmic scale where the variables are changed to log variables. Similarly, the other applications are measuring the intensity of sound or noise level and frequency of musical note. And lastly, not lastly, but yes, most common use of log is measure the pH values of some acidic solution. Okay, pH values. These are also pH value is also measured using log. All right. Next topic is modeling of curves. As we know that analysis of straight line is very easy. Okay, if the relation is of the type y equal to mx plus c, which is a straight line, there are various advantages of a straight line. Means analysis is easier. Why? Because the slope remains constant, and you can also predict some values, because if any variable lies on this straight line, we can predict that yes, this will be the slope of that line, that will be the y-intercept of this. Okay, so basically the analysis of some situation will become easier if we encounter some or if we are able to establish relationship between the variables as a straight line. Okay, analysis of some situations become complex if these are not straight line. Okay, so how logarithms can convert some curved graphs into straight lines. Let us see. There is an example that a water pipe is going to be laid between 2 points, and an investigation is carried out as to how, for a given pressure difference, the rate of flow R liters per second varies with the diameter of the pipe d centimeter. The following data are collected, that as we are increasing the diameter of the pipe from 1, 2, 3, 5 to 10, you can see that rate of flow is increased drastically from 0.02, 0.32 to 200. Okay, so diameter has been increased to from 1 to 10. Okay, but the rate of flow of water, it increases drastically from 0.02 decimal places to 200. Okay, so it is suspected that the relationship between R and D may be of the form of R is equal to K D raised to power n. Why this relationship is suspected? Because this drastic increase in the output, in the rate of flow of water, is only possible if there is some exponential growth of this rate. Okay, so we are assuming that this rate of flow is an exponential curve. It is not a straight line. Okay, where K is some constant. So what we have to do is we have to explain how a graph of log D. Log D means if I take the log of these on both the sides of this equation how the graph of log of this diameter against log of r tells you whether this is a good model for the relationship. Means if we are assuming, if we are suspecting that this is an exponential model of this type, so how logarithm plays an important role, how this log d and log r graph between log d and log r tells you that this is in fact a good relationship that we are suspecting. It is a possible relationship that we can have between r and d. Okay, so how we can do this? So question is, so solution is that if the relationship is of the form, so let us assume that yes, we have this relationship, which is true, we are assuming this. So then taking the logarithm on both the side, this will give you log r is equal to log k plus n log d, like this. So log r is equal to n log d plus log k. Okay, now if you compare this with the equation of a straight line, which is y equal to mx plus c. Okay, what you will notice here that if I change the variable log r to variable y and log d with variable x, because remember we have the variable as r and d. Changing these variable to log variables meaning log r and log d. Okay, so what this turns out into that, and log k is some constant because k is a constant, so log of that constant will again be a different constant, right? So what we can see here that this log r is some variable y, log d is your variable x, and log k is c. So there is a relationship between y equal to mx plus c and this log r plus n log d plus log k is that on y-axis there is log r, on x-axis this is log d. If I make an x-axis not with x, not with d, but with log d, means changing the variables into log d and y variable into log r, I will obtain a relationship which is a straight line. Okay, so log r is equal to n log d plus log k is the equation of a straight line. Okay, consequently, if the graph of log r against log d is a straight line, okay, the model is appropriate for the relationship and n is given by the gradient of the curve. Okay, n is given by the gradient of that curve, because if you compare this log r with mx plus c, this is your x variable, x-axis variable, which is log d. Okay, let me point it out. This is your x-axis variable log d, so the coefficient of this will be the slope of the straight line. So what we need to do is, since the data was collected of diameter d and r, we will make another table which will consist of the variable as log d and log r, and then plot the points. If the resultant points on the graph they form a straight line, then we can say that yes, if they are forming a straight line, that means the relationship that we have proved that this is a straight line, this holds, and if this holds, then the original equation, which was our exponential equation, this holds. So this is the process. Okay, whatever data we have collected, just find out the log of those variables, plot the data. If the resultant data is a straight line, then yes, our relationship holds true. So this is an exponential curve. Okay, so basically we are doing in reverse, assuming first and then proving in reverse. So the value of k is found from the intercept log k of the graph, which is the vertical with the vertical axis. So log k is the y-intercept, so k is 10 raised to power intercept. Okay, so here's the table of log d and log r. Okay, like this. Plot these curves on x and y axis, you will obtain a straight line. Okay, you will obtain a straight line. So this says that in this case, the graph in figure this is indeed a straight line. With gradient as 4, you can measure the gradient of this, and intercept as minus 1.70. Right? So n is 4 and k is 10 raised to power minus 1.74 is equal to this. So the proposed equation linking r and d is a good model. How we can say this? Again, I am repeating that since the variables log r and log d, when they are plotted on x and y axis, these are giving you the straight lines between these two variables log r and log d. Okay, so converting back to exponential form, if this holds true, so exponential form is also holding true, and from this straight line we can estimate the values for some other values of d and r. Okay, and from this value, this straight line, we have determined the value of n and k also. Okay, so now we can put the value of n and k back into our original equation. So r is 0.02 d raised to power 4. Okay, so this whole process we have to do in modeling of curves, and question sometimes comes in the exam for modeling the curves. Okay, so here we have completed our first topic of second unit, logarithms and exponential. Logarithm part is over. In the next video we will do exponential part. Till then, bye bye.